first video on Class B addresses for subnetting. I'm going to start with this example of 5 hosts. So I've gone into start using Class B addresses. So I want 5 hosts. That's my example. I want 5 subnets from this Class B address. The main thing to know that it is Class B that I'm subnetting, and I'm going to move into the 4th octet to use that Class B address and for subnetting purposes. And each subnet is going to have 5 host addresses, so 5 subnets and 5 host addresses per subnet. So here's an example. Here's some layer 3 interconnects. Each of these is a broadcast domain. So in this case, I've got 5 subnets. This one between these layer 3 switches, and I've got one between switches, between the router and switch, and then one between these 2 routers. And a lot of these additional interfaces are used for redundancy and load balancing. So they're a bunch of layer 3 interconnects, so I'm going to assign IP addresses to them, but I don't need a lot of host addresses to do it. So what's the subnet mask for 5 hosts per subnet? So on the table, start over here, and 2's not enough, so I have to go to the next one. That's 6 hosts, so that'll work. That's what I'll use, and that's 3 host bits are used for the host addresses and 5 for subnet bits. And it's a /29. So the subnet mask over here, I've got 3 bits available for host addressing, and I've got 5 bits available for subnets. And so that's easy enough. It'll give me actually 7 host addresses, but I'm only going to use 5. So number of host calculations, so starting from the right, so that's 1, 2, and 4. That's where I'm getting the 7 from, plus the number 0 is 8 addresses, minus the 2 that I have to subtract for network and broadcast. That's where I get the 6 from the subnetting table. So 6 addresses available. And I'm going to calculate the number of bits available for subnets. So through here, I've done this already, but I'll show you 5 subnet bits and 32 subnets. So that does the calculation for me. I know it's 32 subnets available. And that's a lot more than I need, but that's what I have to use to get only a smaller number of hosts that I really only require. So there's the 5 leftmost bits. That's the 5 bits I'm going to use for subnets. And there's the 3 bits for hosts. 2 to the 5 is 32. That's just more of the binary math, where you get the 32 subnets from. And there's a maximum of 6 hosts per subnet. So you've got 32 different subnets, so lots more interconnects you can add with 32 different subnets as your network gets more complex, and you're doing it from that single network address. So identify the subnet multiple to assign subnets. The subnet mask is /29, so 5 bits past the 24, so there it is there. So 1, 2, 4, and there's 8. So there's the bit position 4 has a value of 8, so that's the multiple right there. So 8, 16, 24, just keep adding 8, and that'll give you the subnets. There's 32 available, as we know from the subnetting table. So now to calculate the network address, broadcast, and host range. So we know that 0 subnets available, and you can start with that if you want to. There's 6 hosts per subnet, and there's my multiple. So I started out with this /24. What it does, it denotes the fact that I'm taking a Class B, converting it into a Class C address. So what I have to do, if I do that, I'm extending the subnet mask along to the 4th octet. But I do have to assign something to that 3rd octet, and it's arbitrary as well. It's 1 through 255 possible numbers. I chose 1, but I could have chose 2 or 3 or something else. The other thing I could have done is I could have chose 172.17.1 as well, because that's still within the private IP address range of 172.16 to 172.31. So these are somewhat arbitrary, but often they're selected for good reasons as well. So it's a little of both, and there's 32 subnets I'm going to generate from that. So there's 5 subnets, each defined. I've got the interconnects that require 5 subnets altogether based on the network design. And there's my 0 subnet, so 172.16.1.0/29. Then the host range starts at 1 through 6, because that's the number of host addresses, and 7 for the broadcast. We've gone through this video, so you kind of know how it works now. There's the .8, .16, .24, and .32 address. I've got 32 subnets, but I'm only using 5 currently, and that's how I would assign them. So this would be the 0 subnet. There's the .8, 16, 24, and 32. Often a data center, for example, where you get this kind of complexity.